Okay, wonderful. So to anyone who hasn't met me, and I appreciate that I am somewhat conspicuous, my whole bit is I've written a couple of kids' books about programming in JavaScript, and I perpetually play with technology, building stupid things, mostly. But mostly, actually, I've spent the past 20 years trying to teach people how to write a single unit test. Just one, ideally, just one, in every technology and every language that possibly exists. So I'm going to tell you a little bit about my journey. So hands up if you've ever written a unit test. Okay, that's great. We're about halfway. How many of you have written a unit test in JavaScript? Okay, really good.
How many of you are lying?
Right, so the first bit is going to be really, really obvious, but this talk is one of these, really. So we're going to see how deep this iceberg goes. So a good portion of my own journey with software testing involved good fortune, meeting the right people at the right time, mostly by chance. So I'm originally a self-taught developer, and I'll tell you a really dubious secret, which is for the first 10 years of my career, I hadn't written a single unit test, and everything worked just fine, which I'm sure is a very familiar experience. So, my code kind of worked. I didn't know what I didn't know, and I was happy. I made it through the entirety of an early 2000s computer science degree with nothing but the most casual reference to a unit test being made at all. Oops. So there were entire modules in my degree on software testing life cycles. Not one of them mentioned unit testing, not a single one. Test plans, test scripts, it was all very 1990s, we'll go with that. So, and I was lucky because in my very first job out of university, I had a mentor that introduced me to then relatively nascent discipline of unit testing and TDD. I really haven't stopped writing tests since, which is the honest story. So I'm sure Andy Longshore is never going to see this, but thank you, Andy. You really did change my career, and we should always be thankful for the people that helped us. And I was barely more than a precocious teen out of university, honestly. So while this talk on the surface is about how to write tests that survive, and I'm doing it in JavaScript, I suppose there's also a little bit of my own journey in this with testing and how it changed the path of my career. It's going to be one of those sessions where we start somewhere really, really obvious and end up somewhere really, really that you might not expect. So stick with me through the first bit. I'll go fast, seeing as you've actually written tests before. So we're going to start by covering some of the real basics around, why we test. People often ask me why I'm so enthusiastic about automated testing, because it's the boring stuff, it's the tedious bit of software. But for me, testing is it's this fundamental, beautiful thing. Testing is the thing that we have that's fundamentally of software. It's the thing that isn't borrowed or mimicked from some other discipline. It's the only thing that proves our software actually works. I feel like I need to keep on doing that. So whenever I'm faced with folks asking me, what do I not need to test? Why should I test this thing or that thing? Surely it's obvious. I always answer with the same response, which is, well, which bit of your software are you happy failing in production? That's the bit you shouldn't test, because it will. And what I'm not going to say is that writing tests is going to stop your software failing in production. What it's going to do is that when your software fails in production, it will help you exactly triangulate where the problem is. Very, very different kind of thing. Your software will fail every time, guarantee. So I want to talk about the very foundational basics of testing, and since you've all written tests, we're going to move quickly. So first, let's do the definition, right? So in computer programming, I have to read this. Unit testing is a software testing method by which individual units of source code, sets of one or more computer programming modules together with associated control data and usage procedures and operating procedures are tested to determine whether they are fit for use. Thanks, Wikipedia. I truly don't know who writes in that style ever, but it's everyone on Wikipedia. So I want to start about talking about the humble garden variety unit test, what it is, but more importantly, what it isn't. So unit tests test functions. The unit of isolation, the thing that we are testing, it's a single function. Sometimes units refer to single classes, but the word unit actually means something. Unit tests are written with the help of a testing framework, and your test code is executed using a test runner, the thing that discovers the code and executes it. Unit tests contain one or more assertions, lines of code that verify the outputs of a function or a class or a program, right? real basics. Because we're at a JavaScript conference, I need to talk about frameworks. Sorry. So as with most things in the JavaScript ecosystem, the framework wars were bloody and there were no victors, and there were nothing but bodies on the road on the way. We're going to talk about Jest. We're going to talk about Jest because Facebook wrote it. Jest is all of those things I described in the previous slide, and it's the most common testing framework that you will see in JavaScript. It's not the only tool available. Actually, it's following in the path of libraries like Jasmine and Mocha from the early 2010s that made this stuff, I wouldn't say popular, but made this stuff something you could actually do in JavaScript. And it's soon to be succeeded. I've been using Vitest recently, which is kind of works along with the V project, and it's just better in every way. But we're going to talk about Jest to start off with. It works with all the things you know. So I want to talk about Jest, and I want to talk about the idea of an XUnit framework. Has anyone heard of the term XUnit that isn't a .NET dev? Right, okay, cool. Next layer down in the iceberg. So XUnit is the name for the loose family of frameworks that implements roughly the same pattern of test fixtures and test cases. Now, regardless of the language you're working in, there's a good chance that the most popular test framework in your language is an XUnit framework. It's Jest in JavaScript, it's NUnit in C#, it's JUnit in Java. In fact, the very first XUnit style framework was SUnit in Smalltalk. All of these test frameworks look exactly the same, and they work in exactly the same way. So Jest is maintained and supported by Facebook, and it's used to test React, generally under Node, also in the browser, and it contains a test framework, a test runner, and an assertion library, all bundled into one. So assertions, I don't expect you to read all of that, don't worry. Assertions are used to verify the output of your functions. Most assertion libraries are just syntactic sugar over the idea of some conditional checks. If some condition is not met, throw an exception. The truth is, in 2022, almost all testing libraries are fine. Like, you got an XUnit testing library, it's fine. Don't worry about it. They all have their individual quirks, but you can do this using whatever things that your workplace makes you use. Now, people seem to think the state of testing in the wild looks like this, right? You've probably all seen this diagram. Maybe you've seen some people talk about the testing hourglass. People like drawing pictures about tests, which is really weird. Actually, though, it's more like this. So unit tests are just one of an increasingly broad category of tests. So we've got unit tests, we've got integration tests, we've got acceptance tests, end-to-end tests, smoke tests, consumer-driven contract tests, toxicity tests, UI automation tests, mutation testing. Hey, what about BDD? Acceptance-driven development. Like, there's a whole constellation of testing disciplines that exist, and different kinds of tests are designed to help you at different times in your development workflow. And really, it depends on what you're doing. So at build time, you have problems like your code breaks, or basic integration between components and other nasty code shit, right? And the solution is unit tests and coverage. Coverage isn't correctness, as everyone will bang the drum if you've ever heard anyone talk about it. We have integration tests, traditionally called cross-unit tests, way back in the dark days of literally the 80s. And they have commonalities where all the dependencies are mocked, and you can always kind of mock and stub things, and we'll talk a little bit about mocking and stubbing later. At deploy time, you use different categories of tests. So the patterns are often kind of environmental errors or related to downstream systems. They're slower to diagnose and debug. You have different needs. So the solutions there are kind of end-to-end acceptance tests, but without the mocks, or smoke tests that run against your real live production environment. And then, we have some honorable mentions at system integration time, where we've got continuous running tests against an environment, consumer-driven contract tests to test downstream systems, return the same kind of data structures that you're expecting, toxicity and quality tests to make sure code quality doesn't decrease. These are all part of the same family of stuff, right? And all these kinds of tests just help you fail faster. But we don't want to fail. I hear you all share. How do we use tests to make us do good work? So it's a diverse list, but let's get really, really practical. So it's probably worth highlighting that while I'd love to be brave and do some live code here, one, the TVs are relatively small, and two, I don't trust conference Wi-Fi. Never have, never will, not going to happen, especially not with NPM. So many people will interact with code bases at some point after they've been set up. So it's very, very common. Like if you've all, I saw a lot of hands go up when you said you'd written tests. How many of you have ever set up testing in a project? Right, that's like definitely a third of the people that said they've written tests, right? And it's no secret that the JavaScript ecosystem is wide and complex. It's easy to think that you need a whole bunch of tooling, like Webpack and compilers and like God knows what else to get started. But really, you just need a new NPM project and like a really small number of packages to get started with Jest. So much in the same way that people don't know how to set up React anymore, we're going to talk about how to set up Jest from the start. So presuming that we already have a modern version of Node installed, like 16 plus or something, what we're going to do is we're going to node and knit a new application, and we're going to need 3 packages. We need Jest, we need Jest CLI, I think that may have recently been deprecated, and we need the wonderfully named Babel preset env package. That's really all we need. So Jest is the test framework, Jest CLI is the test runner, and Babel preset env, here's the sentence, is a plugin for Babel which Jest uses implicitly that allow you to write JavaScript code that targets the currently installed version of your runtime. Cool, thanks JavaScript. What we need that to use modules in our tests, and modules are really important in 2018 plus, really. So once we've done npm and knit, and this is pretty small, you'll be presented with an empty directory and a package.json file in it, and what we're going to do is we're going to tweak our package.json so our tests work out of the box. We want to first enable ES6 modules, and we do that by setting that type equals module flag. Everyone should be using ES6 modules in 2022. I absolutely beg you, burn Webpack, throw it in the fire, never look at it again. It's a piece of garbage. Don't use it, it'll hurt you only. So by setting that type property, modules work, and you can use code like you would in any programming language that works. Next, we're going to update our scripts configuration to call Jest. Now you'll have done this before. This just means that when we type npm run test, it'll invoke Jest. Now you could install Jest globally. Don't do that. Don't use global dependencies. Also a really bad idea that lots and lots of people do. Just install it, put a script in. Much better. And then finally, we're going to add some Babel configuration to tell the version of Babel supported by Jest to target the current node version. This configuration looks like bonkers stuff at first. It's bracket soup. You only have to do it once, and then you never have to think about it again. More modern test frameworks like Vitest, you don't need to do this. If you're using TypeScript, you don't need to do this because the TypeScript compiler will take care of it. But that'll get you over the hump. So now let's take a look at a really, really basic Jest test. Now, can you actually see this? This is going to be interesting. So first note that we've called it index.spec.js. Now, Jest by default uses a spec extension. I could change it to test, which I prefer and is what every other XUnit framework does, but let's keep the defaults. And I want us to go through a few things. So we have a file that exports a single function here on the right. And now on the left, there's a test file illustrating Jest standard testing conventions. So we've got like an import for our code, then we've got a describe block with an embedded closure for our tests, and an it block with our tests inside of it. Now the it block is our test, and the name of the test is in brackets, and our names should follow a very, very simple pattern. What happened, under what condition, and what your expected output is. There is no other good way to name tests. Simple as that. It's also worth noting that we're using, again, native import and export statements, which came from that Babel preset env import soup. Now, if you've not done much JavaScript in a long time, I'm happy to report that classes work now. And you can use them in exactly the same way you would use classes in any other language. You might have heard 1,000 people blog about how functional programming is the only way to write JavaScript. And they're like, oh, classes are disgusting, you should never use them. Well, they're not real, they're lies. Classes work fine. Use code organizational patterns that are built into the language for the reasons they were built into the language, please. So this stuff works fine with classes as well as it works with functions. And it works. So, you two now can do TDD in JavaScript without any weird tooling or complicated setup. That's the whole story. It's about as close to using an XUnit framework in any roughly comparable language. And if you like, you can configure like a watch task to run your tests continuously. Next bit down on the iceberg, right? We've probably been here before. Everyone raise their hands. So if that's unit testing, what on earth is TDD? Test-driven development is a software development process that relies on the repetition of a very, very short development cycle. Now, requirements are turned into very specific test cases, and then software is improved to pass the new tests only. Now, this is opposed to software development that allows software to be added that is not stated to meet any requirements. Now, this book was first published in 2003. Has anyone here done TDD? Does anyone here do it every day?
Every day?
Every day.
Can they do once?
This is Kent Beck. Now, Kent Beck, in his own words, is not a great programmer, just a good programmer with great habits. Kent Beck is like the good old white guy. All the rest of them are rubbish. Kent Beck's like, I mean, he worked at Facebook, so, but like, generally his work has stood the test of time as a general rule. Now, TDD was part of a broader XP, the extreme programming movement in the late 90s, and Test First was a promoted concept from XP in like 1999. So Kent Beck, actually, being wonderfully Kent Beck and humble, always just says he rediscovered it. So the quote is this: the original description of TDD was in an ancient book about programming. It said you take an input tape and manually type the output tape that you expect. The program then runs until the actual output tape matches the expected output. Now, after I'd written the first XUnit framework in Smalltalk, I remembered reading this and tried it out, and this was the origin of TDD. So when describing TDD to older programmers, I often hear them say to me, well, of course, how else could you do this? So our unit tests are about testing units of code, mean necromancy. They're not a workflow. They're not a process, they're not a methodology, they're just a programming tool. Unit tests verifying the correctness of your implementation, that's their entire job, that's what they do. Whereas test-driven development is all about building out pieces of functionality, of behavior, and verifying that instead. TDD is a working practice, it's an approach, with the tests you produce existing almost as a side effect. The TDD method, very, very frequently, is just described as red, green, refactor, right? Like this is a very, very common thing you'll hear. So in the red phase, your challenge is to get something working, whatever the cost. There's an exciting talk about Copilot coming up later. Previously, we just copy the code off Stack Overflow. Now we just let Copilot generate our red to green kind of failing test to passing test bit. As Beck says, during this phase, you can commit whatever sins you like, because just for a moment, working trumps all other considerations and aesthetic sensibilities. And I love that kind of feely nature of it, right? The people that get TDD wrong then stop. Red, green, cool, ship it. The important bit about TDD is you spend the time reflecting and you refactor. You change literally the factoring and not the function of your code. The test doesn't change. How you make the test pass changes completely. You go from committing any number of sins to ideally only committing your favorite ones. So as Beck says, the different phases have a different purpose. They call for a different style of solution, different aesthetic viewpoints. The first three phases need to go quickly so we get to a known state with new functionality. That's that same book. Okay, so after the brief history lesson in the origins of TDD and unit testing, let's go back to the good stuff. Now, the thing about those TDD workflows, they mean that you end up running your code a lot, like so frequently that those keyboard shortcuts will wear out on your keyboard, right? Because if you're doing TDD, you make a change, you run the test, you make a change, you run the tests. And in JavaScript, the standard solution for this is to use like a file watcher. Now, I like continuous test runners. Continuous test runners are the thing that changed my career. Like, I didn't believe that they would work when I first heard of them, and I paired with a guy for 2 days in like 2013 that swore by a continuous test runner, and by the end of the first day I went and bought my own license, and I have never looked back, to the point where I won't use programming languages that don't have continuous test runners. If you've never heard of one before, all that happens is you press a key, the program works out what line of code you changed, what tests are impacted, and reruns them immediately. Now, this is Wallaby. Wallaby is a continuous test runner for JavaScript. And running with Wallaby, you don't need to do a watch. It's a VS Code plugin. It works in, WebStorm. It works in Visual Studio. Works in every IDE. And you press a key, it runs your tests. You get a green light for lines of code where the tests are passing. You make a mistake, the test lines go red. Instant perfect feedback. Buy it. I promise they don't sponsor me to say this. I think it's like a 4-person dev team. They've been working on this for like 10 years. It's freaking brilliant. It's the best money you'll spend. Nag your boss. So now we understand what a test is and how we can run tests. What I want to do is talk a little bit about intentionality in software. This is like the next bit of the iceberg. So I suppose we're going to have to address the elephant in the room. I'm sorry if you're upset. You ready to be really, really mad at me? Burn every copy of the book Clean Code. Every single one of them. Aged really, really poorly, truly not a good book. And it means that we don't have to fuck with that guy with whom we shall not mention. Everyone's least favorite relative. Everything that Kent Beck ever wrote dwarfs the work of the creepy uncle. Clean Code is an extremely dogmatic book, and its presence in the industry has reduced discussions about quality to discussions about naming variables. It's muted conversations about architectural style in the same way that a dogmatic adherence to things like the solid principles has. Its shadow, it's long, its thoughtlessness and dogma followed blindly. Fuck that guy. Heresy. Can't say that about Clean Code. Yeah, there was a point in my career where I too thought that the rules around basic hygiene were what design meant. But instead, over the years, I've come to value intentionality in my code above any kind of set of syntactic rules. And it's the same kind of dogma where, you know, people get really caught up about their linters. It comes from the same place. So what does intentionality mean? Intentionality means that every single character matters. Everything you write matters. The most valuable thing I learned about software was to reason about it like it's a body of literature. It has text, it has subtext, it has authorial intent. Software is the means of communicating intent between developer and developer. Sometimes we get it more right than others, but in writing our code, and especially in writing our tests, I want you to approach the work as if every single character matters. The white space matters, the rhythm of your code matters, naming matters, form matters, function matters, the way you split your code into stanzas matter. They tell something to the reader. Sometimes the reader is you. And when we're talking about writing tests that survive, tests that are legible and tests that are useful, tests that are written with thoughtfulness and intentionality are the things that always survive. Now that sounds really great and abstract, but let's talk about what that really means. So we're going to start out with a few guiding principles that you probably can't read because they're written on yellow. Good tests test the what and not the how. They're not implementation specific. They don't require huge amounts of state to understand. They test single things, be they concepts or outputs, and they need to be just as good as intentional as the code that they are testing. So we're going to do a few patterns, and then we're going to work through a real example from a real open source code base that I found on the internet that I did not write. So this is the AAA pattern. Has anyone heard about the AAA pattern before? Cool, like a handful of people. I like it because it sounds like screaming. Tests should, as a general rule, follow the arrange, act, assert pattern. It makes it easy to understand the intent. The setup, doing the thing, checking what it did. Any test that isn't in that pattern, honestly, is probably garbage, and you've all seen them, like these big, long, sprawling essays of tests, which are just other code that runs code, really. No, the AAA pattern keeps you honest, keeps you concise, and it's tempting to call out what you're doing often with these like horrible little kind of comments like arrange, act, assert. You can remove them, honestly. It's an organizational pattern. You don't need to make your code messy by telling people you know what you're doing. Organization trumps comments always. So where possible, we should use relatively standard names for things like our system under test. So I don't know if you've seen this before, but the idea of using the expression SUT, system under test, for the bit of code that you're actually checking. And what that does is it helps you when you're sight reading through your code, see the difference between all the setup and the stuff that's actually doing the meaty work. It makes it more obvious when you're interacting with test code. We're also using a standard naming pattern for the tests. So I mentioned this before, so formatting aside, the test name should always tell you what you're invoking, under what condition, and what your expectation is. Now, I know in Jest, you can do these kind of cool, scopy, combined things where the describe block then combines as a sentence with the text in your it block, but as long as you have like context, what, output, you're in a good place. So I've borrowed this file, this spec file, from an MIT licensed major open source project on the internet. I'm not going to tell you what it is, it doesn't really matter. It's from some test code regarding the handling of some kind of site configuration. Now, I think in my notes, it tells me what it is. I think it's some kind of content management system library. It's certainly not the worst test file I've ever seen. In fact, this is a really regular, like you see things like this all the time, this horrible, terse noise. And what we're going to do is we're going to go through some refactoring techniques to show you how you can take tests that look like that, which are objectively kind of garbage, make them intentional and make them say something. So firstly, God, that is really small. We should use white space wisely. Now, in this example, one of the handful of problems is this total lack of white space in the test file. What it does is it slows down your reading comprehension. White space exists in code for the same reason it exists in written language, to help direct the reader. You should use it. The file on the left here has absolutely no significant white space, indicating either different tests or different phases of the individual tests. Introducing some new lines, as shown on the right, makes it just a little bit easier to read. You know where the code is separated. People often fall into this trap of making their tests terse, and they mistake uniformity, the way something looks neat and similar, for expressiveness, which is when the form of something looks like what it is and transmits some information. Expressiveness is always better than uniformity because your code does different things. It's far better for distinct parts of your test files and functions to look different. No magic numbers. Again, like magic numbers and test codes, I say magic numbers here, but I basically mean any data that looks real. Here, there's a -1 that's a magic number and it needs a name. I need the author of the test to tell me why -1 is the number. It could be any string, right? Like one of the most common tricks is to make your test data stand out by literally making sure the data and the example variables you use look like garbage, right? It's much better if you're writing a test that requires some valid data that's a string that says this is some valid test data or this is garbage data that should throw an error, than -1 or ABC or some product code that you stole from production. Because if you put those things in there, when I read your tests, I believe that those things are important. You kind of give them value by putting them in your tests. So take them out. Will the test describe them? Thank you.
It's not you.
So in this specific example, we could have also relied on the test to provide this kind of invalid weak context. It's not quite as legible as -1 meaning like an invalid weak. It still feels a little bit magic, but in a test so small, it's...
Can we switch the headphones?
Yeah, let's do that.
It's probably by my laptop over there. I think it's off.
One, two. There we go. Yes, so it's tolerable with a small test to compromise this kind of annotation of variables with names, because when it's something so small, you can comprehend it, because your tests are context sensitive. Again, like the reader has that context when the thing is only that small. This is great, like a test with basically a whole load of bullshit in the middle of it, right? So you really need to avoid anything in your test that doesn't affect the execution of the code that you're running. So here, the unnecessary test data, which is a bunch of HTTP headers for people that can't see it, fools you into thinking that those headers are important. We've basically elevated garbage data into being important. It's impossible to understand what's going on in this test because you're sucker punched by a wall of noise. It's the name of my grindcore album. You need to make sure that when you're specifying the test data, you include only the data that impacts the behavior of the test themselves. Anything else is a distraction and fools the reader into thinking it's required. Remove noise, increase legibility. So now you can see the exact condition that triggers the behavior you're testing for, because our actual implementation only checks the request.method property, which is the only thing that's actually used in the function anyway. It has to be the string get, otherwise an error throws a synthetic example. But slimming that thing down makes your tests more useful. Now, as much as possible, we should also avoid repetition in test data, because the visual noise, again, causes the reader to start skimming, and there's nothing worse when you're looking at a test code base than skimming, because tests are all about the details. So if the things are long and boring and you stop reading them, the tests are useless. So here we have code that requires a whole lot of test data to execute because we're testing two different scenarios. We have two different tests. And what we should do is we should extract the commonalities between the two tests. So by extracting the request construction, we can more clearly see the intent of our code rather than be blindsided by the noise of all that data. So in this example, our valid request with function takes two arguments, one that creates that data structure with a valid shape for the first test, one for the second test. Now, yeah, before anyone says, well, that's technically just drying out your tests, right? You said solid principles were bad. Give me a break. You should strive to remove any statements that are inconsequential from understanding the test. It's also important to use modern language features in your tests, and this is one of the smallest changes which you're definitely not going to be able to see from the audience, which is much to my lament. So it might seem like it's exactly the same as our previous example, but what we're doing in this thing here is we're using more modern JavaScript language features to improve on this visual noise. So here we're using destructuring around the HTTP GET function rather than copying variables. These subtle improvements in languages seem invisible at a skim read and seem really mundane from year to year. I can see you're shouting about you can't read it. Yeah, just trust me, it's there. It makes sense. The developer, what you're doing is you're reducing the cognitive load of the developer who then comes to understand the test later. And if you don't keep your test code bases up to date with language features, much like your actual implementations, over time they will atrophy, they will rot away, and you'll end up with a huge maintenance burden. And then you end up in that place where people are like, oh God, we've got all these tests and they're crap and they don't do anything for us. So you can use this pattern called the test data builder pattern that's quite famous. It's nothing more than taking the setup for your tests and putting it in functions, but you can think of it as like a way to build a pattern of reusable test data that works with a lot of different places of your code in your code base. It's kind of like a domain-specific language for testing your application. So simply any data structures that you use a lot, extract into little helper factory functions that get created so you can use them everywhere, and then you can give them names and you can empower them. A valid request. A request for a customer in this context. You give it all names. So it's trivial to accidentally add dependencies to out-of-process systems you don't control, so you should isolate systems you don't control. Now, if you're caught offline, or maybe you get rate limited by a partner, this is the most obvious kind of place where this affects you. Now, this is the predictable bit about mocking and test isolation. So you can use Jest's built-in mock functions to mock behavior of other modules in your application. It's really important that you only mock things that you don't control. If you find yourself mocking loads of things that you do control, you end up with brittly coupled tests. So Jest's documentation around mocking is like really, really, really terrible, really exceptionally poor. But this is the easiest way to use it. So at the very top of the file, what we're doing is we're mocking out node fetch here. And this prevents any imports from accidentally importing the real dependency rather than our mock. Now, you should be really careful when you introduce mocks into your test code. Because it's the act of swapping out one dependency for another, it's very common that tests written against mocks actually don't work in production because you've screwed up your mock in some way and you're not really writing a meaningful test. Also, it's very, very risky because tests bound to mocks can become brittle. Because what you're really doing when you're writing tests around mocks is testing the specific implementation of a function based on a really specific expectation. So you can use mocks, but try use them to only isolate you from external systems like web APIs or databases or the file system sometimes. Please.
Yeah, I agree the Jest documentation is awful. Where would you recommend instead?
To learn how to write mocks.
No, to what documentation?
There isn't good documentation around this, terribly. Sorry. I'll put the slides online and you can copy this one example. So you assert single concepts. Now, people often mistake this as single tests have single assertions. It's one of the most common mistakes in unit tests, which leads to people copy and pasting things again and again and again. The idea is that what you're doing is making sure that if, for instance, a configuration file has to be in a specific state and it needs 3 variables that always change in the same way, you test them all in one test because that's a concept. So in this example, we're testing that a library can reset its configuration. It clearly contains 2 kinds of config, some kind of global site configuration and then like a regular config value. The ability to reset both of these values are individual features of the code and should be split into 2 separate tests because they're 2 different pieces of behavior. Even though the resulting output looks a bit more copy-pasted, we'll come back and fix that later though. Now we're going to revisit this example file and see if we can apply some of our techniques here. Before we did anything to the file, it looked like this, split over the left and right. If I apply all of those things, it looks like that. And at a distance, you can only kind of see the form of it changing. But what did we do? We reduced the cognitive load so that every single thing you see in the test matters. We introduced white space to help the reader. We split out some concepts into their own tests. But most importantly, and one of the most significant changes, is that we stopped testing the basics again and again in every single test. We stopped checking that things weren't null and things were initialized, and we made them their own tests. The tests were originally relying on distinct tests to cover those scenarios, and again, it obscured the actual intent of what was happening in that test code base. Now, I know it doesn't seem like much, but I hope you'll agree that even at a distance, that looks infinitely better than the big terse wall of text you got hit with. And if you do that to every single test file in your code base, every single line of code matters. That's what I mean when I say be intentional about why you're doing what you're doing. So we've spoken about all this minutiae of increasing the legibility of our tests, but I want to talk about my 2 big rules for testing. You've got to test the what and not the how, always. And testing the capability of codes, not the data in your tests. So testing the exact implementation of a dependency is one of the most common pitfalls in testing. You should be testing outcomes of your system under test, not how they reach their conclusions. Tests that test precise implementations are brittle to changes. You have to rework them if you ever change the code. Tests that test the outcomes of a piece of code survive complete rewrites of their internals without you having to change your test code base. And that's the stuff that makes you safe, because you can go and chainsaw through systems and still have effective test output. So in this example, we're asserting explicitly that our weather API is called by URL, but it's a leaky abstraction. We've got like API keys glued in there, and like if this ever changes, or the API key ever changes, the tests all blow. It's not a real failure, it's just some configuration change. So if we change our weather API, this test will still pass. Perhaps, with a single change to our weather API returns temp helper function. So we captured our mock behavior in this one place, and then any other tests that orchestrate over our system will all pass if we just change that one line of code. So it's important to note that we are still exposed to some degree of the implementation. There's still that little bit of knowledge about how the API works. But it's okay if you have to change an abstraction to make all your tests still pass. What you're doing is you're reducing the blast radius of changes rather than having rippling changes that affect your whole code base. And obviously don't hard-code API keys. So the best example I always use of testing capabilities over data is the diamond catter. Has anyone ever seen this before? The diamond catter is amazing. It's my favorite thing in all of TDD teaching. So the diamond catter is this. I give you a letter of the alphabet, you make some ASCII art with that letter as the midpoint. I give you A, you output A. I give you B, you output space A space, B space B, space A space. A little diamond, right? Kind of looks like this. The reason why it's a tricky TDD catter is the alphabet is a really well-known class of data. People really fall into this trap of trying to test the data because we all know the 26 letters of the alphabet. Now, it's not too difficult. There's like 20 ways of solving it. I'm going to use this one here. Don't bother reading it. All it does is it generates the top half goes halfway, flips it to the bottom half, and then pads it out. Right, real simple. If you're interested, Google it. It's great. So this is an example of the kind of test I often see for the diamond cutter. They're ocean boiling tests that not only are testing the data, but they're very hard to incrementally TDD because they require an entire working full solution to pass. So if you write tests like this, where it's like the first one is given A, I get A, given B, I get the whole solution, you're testing everything. You can't break that into small steps because it's pretty much, it's this thing here, like it's the whole fucking L, right? So a better solution focuses on the capabilities of the code. You'll notice in these tests we go out of our way to only split this thing up into really small things. So I'm testing things here like the diamond is always exactly a certain height. The letter on the first line is the same as the letter on the last line. The middle line contains the character that I input. The characters appear twice when they're not A. You separate the data into classes of data and then describe the capabilities of the code, what it does, rather than how it does it and what its specific data output is. Those tests, you can change your implementation every single time and they'll still work. Some people allude to this being kind of property-based testing. You might hear it described in that way, but it's a much more survivable, less brittle way of writing tests. So what we've done is we've arrived at this like weird inflection point where we have so many different types of tests that it actually makes things more confusing, not less. People get stuck in this cyclical conversation about what type of tests to use in what context. And because there are just so many definitions floating around and subtle misalignments, like the best example I have is like integration tests, right? Integration tests are dead. If I say to you, what's an integration test? I'll get someone say, oh, well, they're tests that integrate with the database. I get someone say, there are tests that two classes integrate and work together. I get people that say, well, they're everything other than my database. It's like, fucking hell. If all of these phrases basically mean the opposite, they are the literally of programming, where literally can mean figuratively and now actually technically has been redefined to mean literally again. So fuck integration tests. They're dead. They're dead. But at the same time as integration tests having lost their identity, the sentiment behind integration tests is much more powerful. So as our computers have increased in power and have become more sophisticated, that really, really great thing we used to get with unit tests where we had a really fast feedback cycle, you can now test more of your app. More of your app can be tested in memory together than ever, and you can actually forgo some of the lower level tests. So this is where you see this kind of testing hourglass thing that's become popular, right? But the problem is everyone ran to the wrong side of the boat first. They're like, oh, everything's UI automation. No, everything is not UI automation tests unless you want your test suite to be the slowest thing in the world. But there is some truth that there is a category of tests that's emerging that tests basically your whole application in memory and not any of the missing bits in the middle, right? So these kind of full stack tests or in-memory tests or, ironically, integration tests by some definition allow you the liberty to TDD what you want your application's output to be it your website or your API, without really having to worry so much about the traditional low-level definition of like, well, this is a unit test because it tests one function, and this is an integration test because it tests 3 functions, and I should put them in separate folders, right? Actually, all that stuff has stopped being useful to us. You know? The thing about the style is it's kind of a little bit of all the styles mixed together. So why has it been so difficult to name? Well, it's more about workflow and test isolation than what you're actually testing. It's related to the increase in performance of tools over time, but it's okay, and I'd rather us not lose ourselves trying to find definition for something when, you know, we can just use the thing. Let's talk about the qualities. You know, these tests are fast, they execute in memory. Like unit tests, they don't require ordered execution or affect one another. They're not brittle, you can change your implementation. They test high-level business functionality with some low-level detail, and generally should be authored in like a high to low TDD workflow where you write a top-level covering test, and then you find a complicated bit, and you write a unit test, and then you go back up, and you go back down, and you go back up. And that TDD workflow, ironically, has outlived the various styles of testing that it supported. So maybe they're just tests for our program. And actually, there's a great guy called Ian Cooper who just describes this emerging style as developer tests. Cool, nailed it in one. They're just tests, right? So like the most important thing is this TDD workflow. And while writing traditional tests, it was common to start, high and low and high and low. And actually, I've just said all this stuff because I went off script, so we're not going to read that slide at all. We're just going to jump right to the end. So the really interesting thing is this kind of onion peel style of testing of high to low really fits like 1990s N-tier system design. And the tools we have today and continuous test runners put us in a place where we don't need that stuff anymore. We don't need the waste. And much rather tests that are easy to change, because software that lives today is software that can change easily. The more easy and malleable your software is, and by association, the more malleable your tests are, the more successful it'll be to changing requirements. So in the mid-2000s, when lots of thinking was and writing was happening about all these kind of testing pieces, there was this club in London, actually, called the London Extreme Tuesday Club. Great name. They popularized this idea of what later became known as mockist testing, which is this idea that you mock every tier of your application and test the interactions on the boundaries. But it's crap. It's crap. Honestly, that onion peel approach where each layer was the thing, where each layer was tested was the thing they were promoting. And it was promoted as a more, as an alternative to traditional TDD, which was just test your application. I think the new wave of developer tests both replaces that style and illuminates the negative side effect it's had on our entire industry of people not trusting tests and not believing in TDD because they've ended up with brittle test code bases. The London school, the mockist style testing, is brittle and it doesn't last. Don't do it. Thank you very much. That's my abridged version of testing. I'd say any questions, but ask me later. I think I've run on by like 1 million hours.